Okay, I have a Chamberlain garage door opener, model number 1255LMCR. That's the 120 volts, 5 amp, half horsepower unit. And it suffered a power surge. And the power surge damaged the control board. Control board on these has this part number, 41A5021-1G. And a little bit of research on the web suggested that the solution to this problem is simply to replace the board. But having the capability to repair circuit boards, I've chosen to actually look the board over and see what I could find wrong with it. And I've removed the board, and this is it. And let's see if we can put a little bit more light on this. Not sure if that's better or worse. Let's try a different shade of lighting. It's probably best right there. And my first approach to it was just inspection. There's a couple of capacitors here, and those both look okay. There was a little bit of smoke accumulation on various parts, suggesting something burned. But the board is in close proximity to some of the drive mechanism, and I thought that might just be, I don't know, grease, oil. But I cleaned it up anyways. I've swabbed most of it off and cleaned it up. The other thing that tends to go is diodes. So I checked this diode. I actually removed the diodes from the board and checked them. And that diode was fine. Got a jumper down here, another jumper, capacitor. I didn't remove these capacitors and check them, which is the proper way to do it, but none of these capacitors are swollen. These jumpers seem to be fine. Another capacitor. It has an integrated circuit control chip on it. And can I get the light right here for you to read that? There we go. It's an LM2902N. I do not suspect a problem with the chip. Really what I suspect is a problem with power distribution. So once the power comes in, is the power even getting to the board? There's another link of some kind, the X1, not sure what that is. Got a capacitor, resistor, we got a transistor involved in AC to DC conversion. We got a jumper, another capacitor, which also look fine. There's a diode right there where I'll just move my cursor onto it. There's a diode. I pulled that one and checked it. There's another diode in here. I pulled that one and checked it. There's another diode in here. You can't really see it because of the lighting. But down in there, there's one. I pulled it and checked it. And then there's a couple more, or four more down here below the transformer. And I pulled all those and checked them as well. So all these diodes were okay. Really, that only left a couple of things. It left either these relays, this relay, or this relay, or it left the transformer. And most of the smoke damage was actually around the transformer. And one of these relays, I've actually released the cover on it, and I checked it inside, and there are no broken wires in the windings and no sign of any temperature problems in there. I don't think the power ever got to this relay. So that left the transformer, and if we invert the board and take a look at the transformer connections, I've actually unsoldered this already. I took my heat gun and I heated up these connections, and these central connections here, these three and these three actually are just anchors, and only these ones actually go to circuits, these outer connectors. And you can see that. You see on the circuit board that there are traces running off of those ones. So I desoldered it to check it. So that makes it removable. And if we remove that, let's take a look at it inside. Well, right away, what jumped out at me was these little blobs on the wires. So I'm going to take some fine tweezers here. See this little blob on the wire, another little blob on the wire there, and another little blob on the wire there. And there's one you can barely see up in here. Well, it looks like it got shocked or something or broke. So then I lift it up on the wire, and you can see this wire is actually broken. It's disconnected. So there's been a power surge, and the power surge overloaded this. And I actually know how much the power surge was. It was 240 or 240 volts instead of 120, which is a lot. Now the fine winding here is the primary winding. I know it's the primary because there's more windings on that one than there is on the other one. And this is a step-down transformer. It goes from 120 volts to 22 volts. So in a step-down transformer, you go from high number of windings to a low number of windings. That's just for information's sake. Really what this boils down to is this transformer is shot. So I have to replace the transformer. And I found one online out of the US, and I've ordered it, and it's coming up. Well, maybe an easier solution for you and a quicker solution is just get on Facebook Marketplace and see if there's a garage door opener for sale that matches yours. And then you can just pull the circuit panel and transfer it over. Or you could reinstall the entire unit, the drive chain and the whole works, put it in to replace the one that you currently have. In either case, I was looking at about the same price. I found some on Facebook Marketplace, and they were as cheap as $50 up to a couple $100. And this transformer I found for $70 US, and then about $30 shipping. And it was a certified transformer, guaranteed for a year. So ordered that, and it's coming up. Hope this helped you out. As far as removing the panel from the unit itself, you can find lots of videos online that tell you how to switch out one of those controller panels. And I'm not going to go into that. Thanks for watching.